Hello, myself is Devashish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions, and I welcome you all to this special webinar today. And today's topic is a very interesting one. That is the QoS, quality of service. We'll talk about the basics of the QoS. What is the QoS? What is the requirement of the quality of service? What quality I'm talking about? What is the service after all? And we'll also do some basic configurations of the QoS. So let's begin. So we'll be talking about the quality of service and we'll understand the fundamentals of quality of service and its configuration in network management. So quality of service means what? I'm not going to talk about any quality of any service, but it is something else. It is like whenever you are going to prevent the congestion in the network. So if there is network congestion, you have to have the quality of service in place. If you do not have any network congestion, everything is running smoothly, definitely you do not need any quality of service. Like say for example, you are pinging any host and the reply is coming in, let's say, 1 millisecond interval. That is a normal delay. That is not the congestion. But if it is like 1 millisecond, then 4 millisecond, 10 millisecond, again it's dropped to 3 millisecond, definitely it is uneven delay. That is the result of a jitter. That is called as jitter, and quality of service should be implemented only when you are having jitter, because jitter is actually hampering your network performance. Now we'll understand the quality of service in detail. Quality of service is a crucial aspect of networking and determines how well a network performs in delivering a reliable experience. Definitely, because the network should be reliable. If the network is not reliable, if it is too much delayed, definitely the latency will increase, and latency increases means your cost will go up. So definitely you shouldn't want that. It involves various methods to manage traffic, ensuring specific types of data are prioritized. Is the priority that you are talking about for optimal delivery and performance, and then by it enhances the user's overall experience. Now, what is the importance of QoS in networking? It reduces latency and jitter that I was talking about. QoS significantly enhances user experience by minimizing the latency and jitter and leading to smoother experience. Definitely, if the latency is there, like your say video call or webinar is going on and latency is there, definitely it would be delayed and the customers will be agitated. So you should not want that. Then prioritizes critical applications. It is all about priority. Means say for example, you are actually having voice, video and data. These are the three types of traffic you are having. So you have to give priority to voice by guaranteeing necessary bandwidth for, let's say, critical applications. Now QoS prioritizes essential data and it ensures that important operations are not disrupted. So you have to give priority to data that which is more important. That should be entered first and then other traffics. And improves resource management. Like efficient resource management through QoS leads to better allocation of bandwidth, reducing the congestion and enhances the overall network performance. Now, understanding the bandwidth, and we have to understand the impact of the latency as well. Now, bandwidth is like that's how much distance you have covered against the time. Like if you go back to the bandwidth is the maximum amount of data that can be transferred over a network in a given period of time. So it is calculated from a specific distance, and it is crucial for determining how much information can flow through the network. And the impact of latency is more. Latency measures the delay before a transfer of data begins. There are many delays, like the propagation delay, like when you are actually propagating the data, when there is a serialization delay, when you are actually serializing the data, there is a serialization delay. Different types of delays are there. High latency can lead to a poor user experience, especially in real-time applications like the voice and video calls. So definitely these are the real-time apps. Now definitely delay is not suitable for those. Then types of QoS mechanisms. So what are the mechanisms or what are the steps to implement the QoS? First is traffic shaping. Traffic shaping is a mechanism that actually regulates the data transmission rates by actually controlling the flow of data packets. So you have to reduce the flow of data packet. You have to control that. This helps prevent network congestion by smoothing out burst of data. Burst means excess data. So if you're having say low bandwidth, definitely you will not want the excess data, and ensures that steady flow. Ultimately, it enhances the user experience and say network performance. Then the prioritization, you have to give priority to the data. Prioritization involves categorizing network traffic and ensures that high priority traffic such as video, voice, that is transmitted before less critical traffic like the data. See, you have to first classify the traffic. That is the first thing. Like, which is the traffic that is coming to you, your voice, video, or data. If you do not know your traffic, how can you give priority? And this is vital for maintaining the performance of real-time applications that I've already mentioned. Congestion management is next. Congestion management techniques are designed to detect and control network congestion by regulating the amount of traffic entering the network. So congestion management, it has the policing and the shaping policy. Like, policing means it is a very restrictive policy. Now, if the traffic is coming, is a very important traffic, say video traffic or voice traffic. Let's say voice traffic that is given the EF5, that is the most efficient marking by the service provider. But if the congestion is there, I will not allow it because the policing is there. So shaping is a bit lenient policy. If the congestion is there, it will keep the traffic in the waiting state, in the pause state. It will not drop the packet, but policing will drop it. Now, this is the congestion management, and these techniques help to maintain quality by ensuring that the network can handle the data load effectively without overwhelming resources. Then let's talk about the QoS models and architectures. And we'll talk about a timeline of significant QoS models and their contribution. First is InServ, integrated service. It is introduced to provide end-to-end QoS guarantee, and InServ ensures that network resources are reserved for specific applications. So InServ means that I will reserve a specific bandwidth for specific applications. Let's say telephony applications, any communication applications, telecommunication sector. It is InServ, like that it is actually reserving the bandwidth, even though let's say that device doesn't need that 5 Gbps bandwidth, but I will reserve that. That is the InServ. It is very strict. Then DeepServe, differentiated services. DeepServe developed later, and it enhances the scalability by say classifying and managing traffic into different service levels. Now DeepServe means that if I do not need that amount of bandwidth, let's say I do not need 5 Gbps, I need 4 Gbps. So that 1 Gbps bandwidth will be spared. It will be given to the other classes. Class means voice, video, data. That is a DeepServe. I can share the bandwidth, allowing for efficient utilization of network resources. Then the MPLS, multi-protocol level switching. It further optimizes data forwarding by using predefined labels, as you know, and allowing for faster and more efficient packet switching across the network. Now, why it is MPLS there? Because MPLS also is involved in the QoS, and MPLS also reduces the latency and does the efficient management of data. So these are the models in the QoS. Then essential QoS configuration techniques. Now, how to configure the QoS? Configuring QoS is vital for effective network traffic management, and the key techniques include the defining the traffic classes. So you have to first say, for example, you have to first define the class map. You have to define the classes. Then you have to go for the policy map. So class map will include different classes of traffic, and policy map, there you will prioritize the traffic. You will set different values, QoS values, and then you have to implement it in the interface level with the service policy command. So key techniques include defining traffic classes to categorize data, setting bandwidth limits to ensure fair distribution, and implementing the priority queuing to enhance the performance of critical applications. So there are two queuings, that is CVWF queue, class-based weighted fair queue, where you are guaranteeing the equal amount of bandwidth or the minimum bandwidth to every traffic class, and there is a priority queue, like you are guaranteeing a maximum bandwidth for one class. And definitely both techniques are they will not guarantee you any say congestion free network. Both techniques have some difficulty. So there is policing and shaping to actually restrict the congestion. These methods are essential for optimizing resource allocation and maintaining a seamless user experience. Then implementing QoS in different network environments. Where to implement the QoS? You will implement it in enterprise networks. QoS implementation focuses on prioritizing business critical applications and managing the internal traffic. And it involves defining traffic classes, applying policies for voice and video application, and it ensures reliable bandwidth allocation. Then service provider networks, it is very important because QoS is managed mainly in the ISP, and nowadays it is done through automation, through the scripting. But from a very primitive network till very end, it was done with the CLI command. But now it is done through the automation. Service provider networks require robust QoS strategies to handle diverse customer demands and maintain service quality. And the service provider often implement end-to-end QoS models to ensure that user applications such as streaming data, online gaming, streaming video data receive the necessary bandwidth and low latency. Like your video, your webinar like this going on, and you are seeing that the say the picture is distorted or some voice is not coming clear. So that in that case, service provider network use the QoS. In the cloud data center, cloud environment, yes, in cloud environments, implementing QoS involves managing resources across virtualized infrastructures in multi-cloud environments. Techniques like traffic shaping and load balancing, they are essential to optimize performance, and it ensures that cloud-based applications, cloud apps or web apps, they meet user expectation for speed and reliability. And these apps actually definitely need to be error free, and for that QoS is guaranteed. So, what are the complex configuration issues in the QoS? Implementing QoS often involves indicate configurations that can be overwhelming for network administrators because, say, you are a service provider and you have to maintain QoS for tens of thousands of customers, lakhs of customers. So, how can you manage QoS only with CLI mode? It is difficult. So, nowadays it is done through automation. The complexity arises from the need to define multiple traffic classes and setting that vary across different devices. So that is why you require the automation now. Because in enterprise networking and you go to the service provider level, it is thousands of ACLs, thousands of QoS policies, not one or two. Need for continuous monitoring should be there. Ongoing monitoring is essential for maintaining QoS effectiveness as network conditions frequently change. Definitely have to monitor. This requires continuous assessment of performance metrics and adjustment to configurations, which can be resource intensive and conflict with existing network policy and complicating the process further. So definitely continuous in the network operation center, say for example, you need to have continuous monitoring. So that is, you can say, a time consuming process. Monitoring and managing QoS, a structured approach to ensure ongoing performance and optimization is there. Ongoing continuous assessment of network performance and using specialized tools. So QoS is implemented in, say, ISP level, like when you are, say, buying any data pack for internet and it gives you, say, for example, 2 GB, 3 GB, 4 GB data per day. Who monitors that? It is monitored automatically by QoS policy. Nobody monitors that manually. So that is simplification of the QoS. And it ensures reliable network performance through QoS. Implementing quality of service is vital for optimizing network performance and delivering a consistent user experience. Adopting best practices such as regular reviews of QoS policies, adjustment to accommodate network variations and anomalies, and prioritization of essential applications is very crucial to actually significantly enhance the service quality of your network. So that is about the quality of service basics theory part. And now I will show you how to configure the quality of service. We can configure it in any simulator. We can configure it in the basic, that is the Cisco packet tracer also. But here you cannot take PT router because QoS is not available on all the routers. You have to take 1941. Just give the IP first. Interface gigabit 0 by 0 and gig 0 by 0, no shut. IP address, let's say it's 192.168.0.1, very basic IP I'm giving. Here also on the router 1. Now, first you have to define class map, say ICMP. Then you give match protocol, and you have many protocols like this, ICMP. Exit, and then you give policy map. Policy map, say CCNA, anything. Then you define class, and you have to give a valid class map name, that is ICMP. And then you set IP, that is IP, or say precedence value, say IP, that is a DSCP value. IP, DSCP, these are the markings. That is different DipServ code point. That is the DipServ, differential services code point that I was talking about. What are the markings? You have all these marking. A for the assured forwarding, and EF for the service provider. We do not give the EF markings. That is a very high level, high rated markings there. So you give like the set IPDSC value you set as AF11, and then you can give priority. You can give, say, bandwidth. Let's say give bandwidth, and in the kilobit per second, let's say 100 kilobit per second you specify. So these are the things that you have done, and you implement it in the interface gig 0/0 with service policy, and then give question mark, that is the output, means you are actually redirecting to the other router, that is the output, and on the other router it should be input if you do that output, but because I'm pinging to the other router, and then that is the word means the policy map name. Policy map name is CCNA. Now you just ping the other router 192.168.0.2, and definitely it will ping. First it is dropped for one moment because of the first packet, because of the QoS policy implementation, and then it's pinging. And now if you want to view show, say, policy map, let's say, then you give interface and then gigabit 0/0. You'll see that DHCP AF1111 is set and packets marked as 9. So QoS has marked 9 packets. So your QoS policy is actually working. You again ping the other router, and now you again check the QoS policy map in the interface level. You can see now the packets marked as increased to 14. So this way you can actually monitor the QoS. We cannot monitor it that way like in the ISP. Definitely we cannot do that. But this way you can actually practically configure the QoS. That is very much essential for your CCNA and CCNP certifications. So that is it about the basic of the QoS. QoS is a very big thing, but I've shown you the basic, the theory part and the configuration. It can go all the way up to the CCNP and CCI certification level, but I am here for only the basics, that is the CCNA and basic CCNP level. So this way you can actually create the class map, you can create policy map. Inside the policy map, there can be many class maps. I have only created for the ICMP. Let's say you can create it for the voice. Also, you can create it for the video or any other traffic that you cannot monitor here, because in that case, you need to have some, say, applications like the VLC player or something to test that. Otherwise, the QoS policy, the result will not show up. That is why I am only implementing the ICMP here, the ping protocol. So I guess that is it about the quality of service, the basics of the quality of service theory and its configuration that I have told you in detail. And I hope that you have understood it and it was very helpful for your understanding. And it is very essential to learn this QoS. This is a new topic that is introduced in the CCNA 200301 as well as in the CCNP ENCODE paper. And this is essential to gain all the certifications. And also, I have a great news for you. I have some questionnaire that I prepared for you on the QoS on this topic, and there are say 10 questions. And if you give almost 8 correct answers out of 10 questions, then you have a good chance to earn a certificate. So everybody should attempt this questionnaire right now, as it is very easy and it is from the topics from this webinar itself. So as I've told you, quality of service is a very important part for your network engineering, and as per the service provider is concerned, it is very, very important, because without quality of service, the service provider cannot maintain any traffic policy, anything. Even if you are, say, recharging your internet, that is also part of the QoS. In your YouTube, say you are, say, watching a tutorial on the, say, Cisco topic or any other topic, and your, say, the video is getting paused, that is shaping, because after some time it again starts. If it's policing, it will be totally gone. So policing is not implemented that way. Generally we go for shaping. So this is the things, the skills that you should have for your knowledge and for your certification. And also I hope that you'll be able to incorporate the skills and implement it in your enterprise networking. And also you can serve your networking from the bottlenecks of the performance, and you can enhance the performance of your networking. So that is it from me, from the QoS basics and configuration for today. I will come with some new topic next day. Again, I thank you all for watching this webinar, and I will see you next time. Till then, keep studying and bye.